Welcome to Study Loop.
For the reaction of a part A, proton plus proton gives of proton plus lambda naught plus x. We cancel out proton on both sides using conservation laws, and we can write P is equal to lambda naught plus x. Since the proton and the lambda has a spin, so h cut over 2 and here h cut over 2, this is the spin. The spin angular momentum of x must be 0 here, or h cut. Since the proton has a charge denoted by q here, proton has got a charge of positive e, lambda is a neutral here, so in order to have a conservation of a charge, x must have a positive e charge. Similarly, since the proton and the lambda has a baryon number of positive 1, positive 1. Therefore, the x must have a baryon number of 0 in order to have a conservation of baryon number. Strangeness of a proton is 0, and the strangeness of a lambda is -1. The strangeness of x should be +1. We take the unknown particle to be a spin 0 meson with a charge of positive e and a strangeness of +1. We identify looking in table 44.44-4. This is a K positive particle. Part B of the problem, the analysis that we did earlier in part A, similar analysis tells us that x is a spin minus spin half anti baryon B is equal to -1 with the charge and a strangeness both 0. Inspection of a table 44.3 reveals this to be anti-neutron. Part C, here x is a spin 0, so spin is equal to 0, or spin 1 meson with the charge is equal to 0, strangeness is equal to +1. Looking in the table 44.4, it could be K naught particle.